The film you are about to see was made from 1979 to 1980 by the U.S. Department of the Interior Fish and Wildlife Service, but was never placed in national distribution. It was intended as a training aid to be used in conjunction with live instruction. This is a film primarily about testing ammunition, not waterfowl hunting. The purpose of this film was to document the experimental techniques used in field testing steel shot loads through harvesting wild waterfowl. In the process of this testing, shots were fired over a broad range of distances, short, medium, and long, to determine the performance potentials and limitations of the steel shot shell loads tested. The film was made on location in Northern California and Southern Oregon. Some of the steel shot loads and pellet sizes used were experimental at the time of filming, but are now available as factory loads. All live bird shooting scenes are real and were conducted in the presence of 4 witnesses. The film features a presentation by Tom Roster, at the time a temporary employee of the Fish and Wildlife Service. While segments that depict Mr. Roster downing birds at long range with steel shot are accurate representations of his capabilities, they may not represent the shooting capabilities of other waterfowl hunters. The Fish and Wildlife Service continues to urge hunter caution and discretion regarding appropriate shooting ranges. When the film was made, the reloading equipment shown was experimental. Today, reloading equipment adaptable to steel shot is commercially available. Additional information can be obtained from sporting goods dealers.
Ever since the discovery that waterfowl frequently ingest spent lead shotgun shell pellets and may in turn die from lead poisoning, a suitable non-toxic substitute for lead shot has been sought. Many alternative metal types have been considered and tested, but to date, only steel shot has proven to be both a non-toxic and economically feasible substitute for lead shot. Because waterfowl hunting is rich in tradition, there are many strongly held beliefs and opinions about which shotgun gauges, shot shell loads, and even shot sizes are most effective for hunting ducks or geese. However, there's been very little research to determine the relative performance of shot shell loads on wild waterfowl under actual field conditions. Because steel shot is a new shotgun projectile type, much needs to be learned about its ballistics. That is one of the principal jobs of Tom Roster, a ballistics specialist who works for the U.S. Fish and Wildlife Service. Many hunters are skeptical about steel shot being an acceptable substitute for lead shot. Tom Roster offers some comments on negative attitudes about steel shot.
I think one of the problems that many hunters and many who voice that opinion have is that they have simply never taken a lead shotgun shell, such as this Remington shell, or a steel shotgun shell, such as a Winchester shell, cut them open, remove the pellets and remove the components, and I think if one does that, it tells a very revealing story. For example, if we open up the lead shotgun shell and remove the pellets, remove the wad, we find in many shells today a one-piece wad, which consists of a shot cup, which contains most of the lead shot, a cushioning section, which is very important for helping to prevent the lead pellets from being crushed under the forces of combustion, and then a over-powder section, which gives us a good gas seal and proper combustion. One opens up a steel shotgun shell, you find a different kind of animal. Remove the pellets and remove the wad. You find in modern ammunition, a one-piece wad, but it's noticeably different in design. There's simply a long shot cup and then an over-powder section. There is no cushioning section because steel shot does not need to be cushioned in order to keep it round. We looked at old steel shot ammunition, which I think is a second part of the problem many people have with steel. you will find that the ammunition is noticeably different than modern steel shot ammunition. The old Remington shells, the old Winchester shells, for example, this one had a roll crimp and a little plastic spin-off wad, had troubles with the wads which contain the steel. Here we can see a wad where the steel has impacted in the bottom. This causes the wad, when coming out of the barrel, to tumble, which disrupts patterns. Some old steel ammunition contained simply a shot wrapper on top of a shot of an over-powder wad, and this allowed the shot to contact the barrel to a certain extent and probably resulted in some of the complaints that we originally experienced with barrel or bore scrubbing. Modern steel wads have eliminated those problems. We can see when we recover steel wads, we seldom, if ever, find pellets impacted in the bottom. We never, or I have seldom, if ever, found steel pellets that have cut through the dense plastic that's used, and because these wads completely contain the shot charge, we have eliminated the pellets contacting the barrel and therefore have eliminated barrel erosion with steel shot ammunition.
In order to learn how commercial steel shot shell loads perform, Tom and his assistants use various hunting areas to test the loads on waterfowl in the field. Here at the Tule Lake National Wildlife Refuge in Northern California, Tom gathered some of his data on Winchester and Federal steel shot ammunition to measure its effectiveness in bagging snow geese at 40 yards and beyond. A Remington Model 3200 over and under shotgun was used, choked, improved, modified, and full. Improved modified is a choke constriction that falls between the more common modified and full constrictions. The ammunition tested was 2 3/4 inch 12 gauge, 1 1/4 ounce loads of numbers 4, 2, or 1 steel shot. The most useful shell performance information occurs when only one shot is fired at each bird. The flight attitude of the bird when struck by the shot charge is recorded so that an accurate interpretation can be made of which pellet marks are entrance wounds and which are exit wounds during the laboratory examination, which occurs later. Also recorded is the behavior of the bird after being hit.
Okay. What did you get for distance on that one?
46.
Okay. That was an overhead angle. And I used a Winchester 1 1/4 load of number 2 steel.
All right.
Each bagged bird is individually tagged with a unique code number. On this tag is recorded distance, the angle of the shot, and the type of load. This information is also recorded on a field chart so that it can be correlated in the lab when the necropsies are performed. On this particular day, 5 snow geese were collected with the steel shot test loads.
Now the interesting thing about all of those, both of those 1 1/4 loads now is they've increased the velocity from 1260 to 1330 feet per second.
Each tagged bird is taken to the Oregon Institute of Technology to be X-rayed. X-rays are an important tool in helping researchers accurately measure and interpret certain lethality data. The X-rays allow the researchers to note the precise location of embedded pellets and also to more accurately measure the depth of penetration.
Okay, these X-rays here represent this goose right here. And this one was shot from overhead. It was flying over like so, and it was shot. So the pellet should have gone something like this. And this view here represents where these pellets should be in the bird here. You can see there's 2 here in the head. You can see 2 holes there.
During the necropsy, information relating to the total number of entrance and exit wounds is recorded for each bird. A probe is inserted into each wound channel caused by an embedded pellet. When the probe makes contact with the pellet, the depth of the wound channel from the pellet to the skin line is marked on the probe with the fingers. This depth is then compared to the image on the X-ray, and if there is a close relationship between the two, the distance is then measured on a meter stick and recorded on the data sheet as the depth of penetration.
Okay, now one thing I noticed, you got a pellet, looks like it's embedded here in the knee. It looks like you got 2 embedded in the head. Could you dig those out for me so I could see the change, if any, in spherosity? Now you've got an embedded pellet in the head.
Right.
under the skin.
Right, they came up here under the throat here, and one of them embedded right here just under the skin. It went
So
through the skull.
in other words, it penetrated from here all the way through the head and ended up under the skin. The reason I ask that, we get a lot of people who find pellets under the skin, but because they didn't keep a record on which angle they shot the bird at, they incorrectly assume that that pellet somehow just went under the skin and lodged there. But in this case, because we know that it was an overhead shot, we know that the pellet entered at the throat, penetrated all the way through the head, and ended up just under the skin at the top of the head, which
Right.
we could then remove and study for deformation. Okay, and there's the pellet. The interesting thing about steel pellets are that when you examine them after they've been removed from the bird, no matter how far they've penetrated, they're seldom if ever deformed.
Because some sizes of steel shot are as yet unavailable to the public in commercial ammunition, the service occasionally assembles its own ammunition in order to gain familiarity with the potential of various pellet sizes. At the time this film was made, both number 6 and number BB steel were being tested.
You're going to load the number 6 steel shot with a Federal steel shot 2 3/4 inch 12 gauge hull, a steel shot wad, which I have the pedal pre-bent so it fits into the wad guide on a progressive Pond's Nest worn press, because we can crank steel shot out at a high rate. Simply insert the wad, pull the handle, and presto, we have a loaded steel shot number 6 steel. And I have loaded up some number BB steel. You can see that the crimps are fully the equivalent of a factory load, and I code them a little bit differently than the number 6 steel with a magic marker.
The experimental ammunition is loaded to similar velocity levels and shot charge weights as available in commercial ammunition. Testing of the 2 3/4 inch 12 gauge 1 1/8 ounce load of number BB steel was begun during winter hunting conditions. The test site was north of Klamath Falls, Oregon, and the temperature that day was about 15 degrees Fahrenheit. Roster decided to collect data first on the performance of the experimental number BB steel loads on relatively close shots at Canada geese, that is, goose hunting over decoys. He chose to use open chokes, in this case skeet chokes, in order to increase his opportunity to hit the target at close ranges. Improved cylinder chokes, which are only slightly tighter than skeet chokes, would also be appropriate for shooting at this distance.
Okay, how far was that last shot?
That was 42 yards.
All right, that was left to right and B1.
Mm-hmm.
Data gathered by the U.S. Fish and Wildlife Service on load performance are provided to both the munitions industry and to waterfowl hunters for their consideration.
51. Okay, let's tag this. And see here, it had a couple pretty good chest hits, and that was a B1, died immediately.
Some hunters have reported that when using steel shot to hunt Canada geese, their birds would oftentimes fall to the ground as cripples and either run or fly off. We found, however, that during this test, if the Canada geese were properly caught in a pattern of size BB steel, they were cleanly bagged. This day's activities provided performance data on size BB steel over ranges of 20 to 50 yards. 9 birds were bagged with 10 shells that day. Roster frequently invites waterfowl hunters to help him gather data on steel shot performance. He had heard that professional waterfowl hunting guide Shell Block had been voluntarily shooting steel shot in the Tule Lake, California area. Because of Shell's extensive experience with shooting steel shot, Roster contacted him and asked him to relate his experiences using commercially available steel shot ammunition.
Most of my shooting was from 40 yards and beyond. And I did favor the number 2 and the number 1 steel for that.
For what, ducks or?
For ducks primarily, although I did shoot quite a few geese with them.
What geese? Oh no, what kind?
The geese were mainly white fronts and snow geese. I had very few opportunities to take any of the Canada geese. Over the decoys, the number 4 steel worked very well for ducks, very well.
Well, this is kind of interesting because now you must have read in a lot of the outdoor magazines and places a lot of concern with crippling losses with this stuff. People are really worried they'd get more crippling loss. After you, well, first of all, how many birds did you end up shooting with this stuff?
Well, I shot about a total of 500 ducks and geese with it.
Well, what about cripples? What did you...
The number of cripples I had seemed to be much less shooting the steel than I've ever had with the lead.
No kidding.
And another interesting thing was when we would get a bird down, like on the water, and it was trying to escape to the tules or something, I would shoot at it on the water, and I was able to kill it with just the first shot or two with steel, whereas sometimes when I'd shoot lead at them in past years, it'd take me 4, 5, 6 shells to get them killed.
That's really interesting.
So apparently it was holding much tighter pattern, and it was very easy to kill them on the water with it.
Huh.
Tom Roster and Shell Block then began collecting data on the performance of experimental loads of number 6 steel and commercial loads of number 2 steel for pass shooting ducks at long ranges. Shell decided to use his Remington Model 870 pump with full choke barrel.
Can you pick a Drake mallard?
Yeah, here's one on the left.
This duck was hit with an 1 1/8 ounce load of number 6 steel at just over 43 yards.
Here comes another bunch. Big Drake, straight up.
Okay, I got it.
For this shot, Tom used his Skeet Choke Model 3200.
Oh, it's a good one. You get a distance on that?
Yeah, it was 57 yards.
Okay,
What did you hit him with?
number 2 steel. That was a straight overhead shot.
On this day, a total of 16 Drake mallards and 2 pintails were taken with 28 shots using both the experimental number 6 and number 2 steel loads, primarily at ranges beyond 55 yards.
About 40 to 60 yards.
Tom then traveled to William Finley National Wildlife Refuge near Corvallis, Oregon, to gather information on the performance of size BB steel for long-range shooting at Canada geese. Before beginning the day's activities, Roster explained to Shell Block and research assistant Gary Ivey that William Finley provides primarily pass shots at Canada geese between ranges of 50 and 70 yards. The researchers then moved to an opening in the woods in order to provide them the long-range pass shots they desired, and they awaited the arrival of the geese.
Okay, this was the goose we just bagged. Now, what kind of distance did you get on that?
60 yards.
Okay, and I used the 1 1/8 ounce of number BB steel. And that was what, an overhead angle?
Yeah.
All right, well, this was our second bird we got on the pass shoot. Was a right to left bird. And what distance did you get for it, Gary?
I got 69 yards.
Okay, so he got 69 yards through the rangefinder instrument. And I shot this with the BB reload that travels 1390 feet per second. Used the improved modified choke, and the bird was dead immediately. I can see for sure that there's 1, 2, 3, 4, and 5 pellet strikes in the chest. This is the second bird, a right to left, about 52, 53 yard shot. We can see 1, 2, 3 pellet strikes for sure in this bird, plus a wing break. When we get done autopsying it, we'll determine for sure how many pellet strikes. I used BB steel to collect all of these, which we got 153, 2 about 60, and 2 right around 70 yards.
Back in the laboratory, the necropsies then revealed the story on the number of pellet strikes and their location on each goose.
On this overhead goose, remember this one sailed over the trees and fell in the field dead behind us, and the dog retrieved it. It was about a 60-yard shot, again with an improved modified choke, and I used the 1 1/8 ounce load of number BB steel. We can see very clearly on the autopsy sheet the location of those pellet marks, and they were in the back half of the bird, so the bird usually doesn't fall dead as quickly if they're hit in the back half. So we'll struck with a total of 4 pellets, of which none exited, leaving a total of 4 embedded shot. You can see on the x-ray then the location of the 4 embedded number BB steel pellets. We can see then the depth of penetration. This one penetrated through to here, one through to here, one through to here.
Learning to shoot steel shot well, just like learning to shoot lead shot well, can only be attained by practice. Tom relates his experience.
Before doing any collecting of performance data with steel shot, I had to first train myself to shoot with it. I used the skeet range and got permission from the owner to stand back at 40 to 45 yards in order to practice what to me were the distances and angles that commonly occur during waterfowl hunting. I soon learned that for a person like myself, who has shot many rounds of lead shot throughout his lifetime, that learning to shoot steel was no easy task. Initially, I did a lot of missing before learning finally to consistently hit with steel. And I soon discovered another big truth. It took a lot of practice. One thing this experience did teach me, though, every hunter will need some practice to become a good shot with steel.
In listening to hunters throughout the country talking about shooting steel shot, Roster soon noted a pattern. The more experience a hunter had with shooting lead, the more difficulty he seemed to have in learning to shoot steel. So Roster contacted his old shooting coach, world champion skeet shooter Walt Bedorick, to see if and how Bedorick could learn to shoot steel shot.
Today is to learn to shoot steel.
Okay, now tell me the basic difference between shooting steel and lead as far as the velocity and the different leads at different ranges are concerned.
All right. What we know about steel at this time is, first of all, you're going to have a tighter pattern than you used to with lead shot. Secondly, because the pellets of steel stay round, you're going to have a shorter shot string. In terms of velocity, the lead loads you've been shooting are about 1,200 feet per second, and the steel loads are about 1,365.
To make the comparison, Roster first asked Bedorick to shoot with lead shot target loads. He had him shoot at Station 5 at a skeet range, which presents a 90-degree angle target at 21 yards distance.
Okay, now Walt, we've gone through the basics of shooting and you've shot with lead shot. Now we're going to switch to steel shot. What are you going to do different now when you shoot steel than when you shot lead?
Well, we'll shoot high 5 again here, and when you shoot lead shot, that lead's about 3 feet. So I think the first thing I'll do is cut my lead about in half. So I'll try to look at about 1.5 foot lead. It's going to be a little difficult to teach myself to look for a shorter lead, but I'll try to look for a shorter lead, but do the same thing I've always done with lead, and that is follow on through and keep your head on the stock and just cut the lead down and see how that works to start with.
All right, let's try that.
Oh.
Okay, want to do another one? Yeah. Light's a little lower now.
Oh.
Okay, let's talk about that one a little bit, Walt. Okay, what happened on that shot, do you think?
Well, I might not have had enough lead. I was trying to concentrate on cutting the lead back, and I think I didn't have enough lead, but I'm not positive, and I could have shot over the target a little bit. I really can't tell you right now.
All right, let's try it again.
Oh.
Got that one good, Walt.
Yeah, I think what I did on the other one was cut the lead back down just a little bit too much, and didn't quite have enough lead, and the target got away on me.
All right, so what kind of lead do you think you're using now that you're hitting them?
Well, I'm cutting my lead about in half, so I'm down to about 1.5 foot over a lead shot lead of 3 feet.
All right. Okay, well, that was interesting at 21 yards. It looks like you definitely made an adjustment, cut down your lead, and we're hitting pretty good with steel. Now, coming back here to about 43 yards, we'll be breaking the target. I think it's important to practice back here because that's where a lot of duck hunters shoot their birds, and we'll have to make some more adjustments here. Okay, now Walt, with the steel there now, you've missed a couple, missed several, and hit a couple. What seems to be the problem?
I think on steel, being your shot string is so much shorter, you have to be a much more disciplined shooter. In other words, once you get your lead, you have to pull the trigger. You can't wait on that target because you don't have that long shot string to pick up the tail of the target.
All right.
So you have to be much more aggressive when you're shooting steel shot. And I think that's the only difference right
so
now.
you think when you're breaking those targets, you're slapping that trigger the instant you see that lead?
Right. Once you get the lead that you want, you pull the trigger, there's no problem. But if you wait and hesitate and try to measure the target just a little bit, because of the difference of the shot string, then you find yourself missing the target.
Okay, well, why don't you go out there and work hard and see if you slap that trigger when you see that lead, if we get more breaks.
All right.
Oh. All right, broke that one good, real good.
Some people have theorized that downed birds that are not dead are more likely to escape in the dense vegetation of a wetland environment than on dry land. A dense marsh is an excellent place to examine this question. Some of these data were collected in the marshes of Lower Klamath National Wildlife Refuge in Northern California. Since Tom Roster was in the process of testing the performance of light 12-gauge loads of number 4 and number 2 steel shot, he asked Walt Bedorek if he would be interested in helping. Besides gaining more information with Walt's help, Tom also wanted to learn how much difficulty an experienced lead shot shooter like Bedorek would have in applying what he had learned shooting steel shot on the practice range to shooting waterfowl under actual field conditions. After several more days of clay target practice, Walt agreed to meet Tom at Lower Klamath. For the test, Roster chose to use a Remington 3200 over and under, choked improved cylinder and modified. Bedorek brought along a Miroku over and under, choked, modified, and full. After a short journey into the marsh, the decoys were set out and the men waited for the evening flight. Bedorek missed shots at the first 2 mallards with his full choked barrel at a distance of a little over 35 yards. Roster then began shooting. He took this mallard at about 25 yards with an improved cylinder choke and a Federal 1 1/8 ounce load of number 4 steel.
Well, Tom, you hit those last birds pretty good.
Right, well, what I did is I used my improved cylinder barrel. I cranked out a little extra lead because I was going to school on what you were doing there, and it looked like you were shooting behind a little bit, and I kept saying to myself, well, I would have lead about the same way he was as I was looking down your barrel, but it wasn't quite enough. So I cranked out a little bit more lead. I'd say good.
Bedorek then switched to his modified choke and increased his leads for his next few shots. Bedorek took this Drake mallard at about 40 yards using a Federal 1 1/8 ounce load of number 4 steel. Bedorek took this mallard at a measured 48 yards with his modified choke using a Federal 1 1/8 ounce load of number 4 steel. This duck is typical of what the researchers call a behavior 1 bird. That is, dead or immobile almost immediately. Roster took the remaining shots for the day, which ran between 40 and 55 yards. Steel shot is a sharp break from the lead shot traditions, and it requires some adjustments in your thinking and your shooting. Determining which steel loads and chokes are best for your hunting situation will require some testing by you. It took a good part of your life to learn how to use lead shot, so allow some time for practice with steel shot. By the end of the day, Walt had bagged 6 mallard drakes with 15 shots, and Tom had bagged 5 mallard drakes with 6 shots.